I am on this page in your notes packet. So we're talking about absolute value in inequalities. When we did absolute value equations, we talked about what that really means in words. And what that really means in words is the distance between x and 0 is less than 2. Before we had an equals, it was the absolute value of x equals 2. We said the distance between x and 0 is 2. Now we're saying it's less than 2. So what does that mean? It means that graphically, the distance between my number and 0 has to be less than 2. As a graph, it's going to look like that. I can't include -2 or 2, but anything in between is going to keep the distance under 2. Symbolically, x is between -2 and 2 exclusive. We go back to our set terminology. Alrighty, so this one then is going to say something a little different. The absolute value of x minus 3 is greater than 4. So in words, really think about what that is saying. The distance between x and 3 is greater than 4. The distance between the number that I want to choose and 3 has to be greater than 4. So here's 4 units away from 3. I want to be going in that direction. I want all these numbers included. And in this direction, I want all these numbers included. Graphically, that's going to look like an open circle going down from 0 and an open circle going up from 7. Symbolically, that's x is less than, oh, did I count that wrong? Sorry, guys. I can't count on a number line. That was a -1. Sorry about that. Got to move this guy down now, too. There we go. X is less than -1 or x is greater than 7. I think you have a little thing on your page that says either x minus 3 is greater than 4, in which case you get x is greater than 7, which we have, or, now remember when I talked about this initially and we had the absolute value of x minus 2 equals 7 or something, and I said you're going to break that out into 2 cases and you're going to have x minus 2 equals 7 or the opposite of x minus 2 equals 7. And our shortcut was we just said either x minus 2 equals 7 here or x minus 2 equals -7 here. And the reason we could do that was because we were just taking this negative and moving it to the other side by multiplying both sides by -1. But if you think about absolute value and an inequality versus an equals, when you multiply through an inequality by -1, you have to flip the symbol. This is saying the opposite of x minus 3 is greater than 4. So to multiply both sides by -1, I would have to change that and say less than -4. We get x is less than -1, which is what you saw over to the side. The alternate way of doing this would be to say -x plus 3 is greater than 4. I get -x is greater than 1, and then I would multiply through by -1 or divide through by -1, and it would be x. Either way, I'm still getting that -1. So let's try an example here. The next one, example 1, says the distance between x and -5 is less than or equal to 8. So what's that going to look like from a procedural standpoint? I'm going to have x plus 5 is less than or equal to 8, and I'm going to have the opposite of x plus 5 is less than or equal to 8. So this is going to give me x is less than or equal to 3, and I'm going to move the negative to the other side just because I feel like it, and I want to keep my x positive, so I'm going to get greater than or equal to -8. I multiplied through this whole entire thing essentially by -1, so I have to flip the symbol when I multiply through an inequality by a negative, and then I'm going to get x is greater than or equal to -13. And if you think about this, here's -13, here is 3, and it's greater than or equal to -13, so I use a solid circle here. What I'm talking about is I want to be less than 8 units away from -5. Does that kind of check here? Well, between 5 and -13, it is 8 units, and this is also 8 units. I'm less than or equal to 8 units away from -5. Sort of makes sense? Try number 2 on your own, pause the video, and come back and look at my solution. I have x minus 4 is greater than 3. Opposite of x minus 4 is greater than 3. That's going to give me x is greater than 7, and x minus 4 is less than -3, which gives me x is less than 1. I'm going to graph that, greater than 7, less than 1, and open circles. And if that makes sense, the distance between x and 4 is greater than 3. Well, this distance right here is 3, and this distance right here here is 3, and I want my distance to be greater than that, so it checks. All right, take a look at number 3 and number 4. Try them on your own and come back and check the solutions. For number 3, I would get x plus 3 is greater than or equal to 9. Or the opposite of x plus 3 is greater than or equal to 9, which is going to give me x plus 3 is less than or equal to negative 9, and x is less than or equal to negative 12. And here I would have x is greater than or equal to 6. And so I'm going to have negative 12 and 6 on my number line. I am going to use closed circles, and that's saying the distance between negative 3 and my number is going to be greater than 9. Well, this distance is 9. And this distance is 9, so it does make sense. In number 4, kind of interesting problem, you might have gotten stumped there, but it's going to be the case that x minus 5 is greater than 0, or x minus 5, the opposite of x minus 5, is greater than 0. So I get x is greater than 5, and x minus 5 is greater than, we don't have a negative 0. Well, you multiplied through by a negative here. Sorry, my mistake. 0 can't be negative, but that would still change because I'm multiplying through by the negative 1. X is less than 5. And it's true. This is just saying the distance between my number and 5 is more than 0. Okay? Everything but 5. So that's basically how to solve these. The back is your homework. I will try to post an answer key. See you tomorrow. Have a great night.